In this video, we're going to talk about effective rate and use the effective rate formula to do an example. And so let's first talk about what effective rate is, which is also called annual yield. So it basically is just the simple interest rate that gives you the same value amount of money at the end of a year compared to a compound interest rate. So if you put money into an account that earns compound interest, what would the simple interest rate need to be in order to earn that same amount of money? So the way simple and compound interest works, they don't give you the same amount of money because compound interest will earn more. So they're not going to, the same percentage is not going to earn the same amount of money in both situations. So I think the best way to look at this is to look at the very first example that we did in this module. So in this example, there was a scenario where $5,000 was invested for 3 years at 4%. And we took the same percentage rate and looked at how much simple interest was earned and then compound interest. So using the simple interest formula, we found that $600 was earned in interest if that 4% was simple interest. And then if that interest, that 4% was compound interest calculated or compounded once per year, $674.92 was earned. So you can see that 4% is not the same. 4% simple interest is not the same as 4% compounded interest. And so basically when we're looking at effective rate, we're asking ourselves this question. So we're saying, what is the simple interest rate that would give us the same amount of money, so that's $674.92, as a 4% compounded, and in this case it's yearly rate. So we know 4% isn't enough to compete with a 4% compounding rate, but we may be higher. So we'd probably have to raise that percentage rate. Well, not probably, we would, in order to earn more money. And so it's going to be above 4%. So why don't we do an example and use the effective rate formula so we can see how this works. So the nice thing about the effective rate formula is there aren't too many variables. So E is just effective rate, and then the R and N are the same. They represent the same things as the simple interest formula. Well, R does, and then the compounding interest formula. So N is just the number of compounding per year, and then R is the annual interest rate. And as always, it's as a decimal. Okay, so in this example, we want to find the effective interest rate. So as soon as you see that in a problem, you know, okay, I've got to use this effective rate formula. When the stated rate is 4%, so I'm just going to write down rate is 0.04. Since 4%, we drop the percent sign and we move the decimal, which is always at the end of the number, 2 spots to the left, or we can also divide by 100. And the interest is compounded semi-annually. So a semi-annually means twice a year, so N is going to be 2. Round to the nearest hundredth of a percent. And then remember, with rounding, if you're ever rounding a percentage, you need to convert to a percent and then round. So your rounding is going to occur at the end. So I'm going to use this effective rate formula. So E equals 1 plus my rate over my compounding period raised to my compounding period, so 2 power minus 1. And then you can put this in your calculator a couple different ways. So if you've got a 3430, you can use that N over D button here. So you can type in, press the parenthesis and type it in exactly how it looks. Use the N over D button, so 0.04, down arrow, 2. Make sure you use the right arrow to get out of that fraction, parentheses, and then we could raise it to the second power. You could also use this x squared button. Whoops, we don't want to raise that to the second power. I'll just delete that. And then make sure that you use the right arrow. I believe you can also use the down arrow. Oh, you know what? It doesn't work. We've got to use the right arrow. Glad I tried that. So use the right arrow so it gets you down below. So that way when you put the -1, it's in line with the parentheses and not with that exponent. So -1 and then hit enter. And so we have a rate of 0.0404. If you don't have an N over D button, that's okay. You can still use parentheses 1 plus and do 0.04 divided by 2. Just use the division sign end parentheses, raise it to the 2 power, and then minus 1. So this will work on scientific calculator, it will work on a graphing calculator. If you don't want to deal with the parentheses, you could even enter this stuff first, hit enter, then raise it to the 2nd power, enter, and then subtract 1. So that would be a way to do it without putting it all in at once. Okay, so we've got this answer, we've got a decimal answer. Now our directions say round to the nearest 100th of a percent. So first we need to convert this to a percentage, so we can multiply by 100 or move the decimal 2 spots, right? So we get 4.04%, and then it says round to the nearest hundredth of a percent. So we need to find the hundredth place. So this is the tenths place, hundredth place. It's already rounded to the hundredth place because we don't have any digits after that. So there's no rounding to do. We're left with 4.04%. So basically what this means is it means that a 4.04% simple interest rate is equivalent to a 4% compounded interest rate, assuming that interest is compounded semi-annually or twice a year. So I hope that makes sense, and as always, just contact your teacher if you have any questions.